Hello, I'm Dr. Geoffrey Otieno from the Technical University of Kenya, where I am the director of the School of Chemistry, and I'm a member of the Kenya Chemical Society, where I sit in the governing council. So today's topic is chemical security risks. And the presentation will cover some basics of risks. We will look at chemical risk assessment, and we will conclude those two topics. So our goal is to define risk and differentiate between risk and hazard. We will also look briefly on what affects risk perception, and then we will assess and characterize chemical security risks, and we'll extend it to chemical security threats. So a hazard is something that has the potential to cause harm. And hazards could be a cable on the floor, could be a chemical put on a bench. These two have the potential to do harm. Someone can trip over the cable. In the lab, someone could knock off the chemical from the bench. Now, a hazard is not a risk, because risk will have to involve the situation or the environment in which the hazard is. So a bottle on a table where there are no people really does not pose a risk to anyone. But a bottle at the edge of a table in a busy laboratory is a risk in that it can easily be knocked and harm someone if it spills. So the situation or the environment in which the hazard is leads us to defining a risk. Now, an electrical cable that is passing over a sink, and the sink is metallic, we can pull out, or we can get what the hazards are, the things that have the potential to cause harm. Water touching the cable would result in a short circuit, and particularly the sink now, which is conducting metal, can conduct electricity, and anyone touching that sink could actually be harmed. So the hazard is a combination of the electricity next to running water, which is on a metallic sink. But that is not a risk. The risk happens when there is someone next to this sink where there is running water. The likelihood of an incident occurring in such a scenario where we have a circuit in a metallic sink with water, the likelihood of an incident happening increases, and the consequence could be as dire as death. Now, risk, therefore, is likelihood of an incident happening and the consequence that that incident would result into. Hazard is simply something that has the potential to cause harm. Now, we can map this in a graph. Risk is a function of an incident occurring and the consequence that the incident would result to. Now, if we map this in a graph, if the likelihood of an incident happening is low and the consequence, say, is also low, the consequence could be a burn, we say that that consequence is low. On the other end, a consequence that would be very high is death. So if the likelihood of an incident is very high and the consequence is very high, then we say the risk is very high. If the likelihood of an incident occurring is very low and the consequence is low, then we say the risk is low. Risk involves the situation and not just the hazard. The hazard is anything that can cause you harm. But if the situation is such that no person is going to be in contact or is likely to be in contact with that hazard, then the risk becomes low. But if the situation is such that there is likelihood of someone coming in contact with the hazard, then the risk goes high. So risk perception is something that is innate in human beings. How we perceive risk depends on several things, including the cultural background. In a country where there is no nuclear power or nuclear facilities, the question to the populations about how risky is nuclear power normally results in many of the people saying that it is very risky. But that is not the case. It is more risky for you to drive in your car compared to the generation of energy from nuclear. The reality is that nuclear energy is actually very safe, but it is simply a perception that nuclear is dangerous. Risk perception affects how we think of chemical security. Classification of or identification of risks using likelihood and consequence is needed for us to identify which chemicals are actually risky and what situation actually makes them to be risky. So risk applies both to safety and security. So a safety incident, for example, would be a spill, or if you're in the lab, some uncontrolled reaction. All these things are unintentional. A security incident, on the other hand, would be theft, where chemical is targeted for some malicious use. A security incident could also be sabotage or some unintentional release by a disgruntled employee or an intentional release by, say, a competitor. The characterization of safety risks is nearly the same as the characterization of security risks, only the components change. So let's look at chemical safety risk characterization. The risks in terms of safety can either be low, moderate, or high. And in low risk regime or region, this can be characterized by having routine procedures. Also, a good characteristic of low safety risks is the use of benign or materials that are not very harmful. The volumes of the chemicals being used in the low safety risk regime also are small. So we are not involving ourselves with large volumes of chemicals. Now, an incident in the low safety regime is likely not to lead to an emergency. Therefore, mitigations in place are adequate to take care of these low chemical safety risks. On the other hand, where we have a high safety risk, now this region is characterized by extremely delicate procedures, and these procedures can easily go wrong and result in an incident. Now, the region is also characterized by staff who are not well trained or who are inexperienced. This kind of staff would easily lead to an incident, a chemical incident occurring. Now, the materials used in where we have a high risk, chemical safety risks, are toxic, they are reactive, they could be explosive, and it is likely they'll be present in large quantities. This all characterize high safety risk. An incident in a high safety risk is likely to result in loss of life, loss of property, and it is likely to lead to a serious emergency situation. Now, security risks, on the other hand, unlike safety risks, are focused on protecting our chemicals from threats. Threats are people who would want to take the chemicals and use them to harm others. Now, the low security risk region, the assets, which are the chemicals, would be targeted for theft or diversion, and the consequence of the loss or release of these chemicals is low. The consequence is not going to result in loss of lives or serious loss of damage to property. On the other end, the high security risk situations, the assets tend to be very valuable, and they tend to be the difficult to acquire dual use chemicals or materials. And the consequence that would result in the high security risk are likely to result in death or serious damage or loss in property. So how do we reduce risks? We can put in place administrative controls. That is, for example, using badges for identification, having proper inventory management systems. So decreasing risk means that we have to do two things. We reduce likelihood and we also reduce the consequence. So by putting in place the right measures, for example, wearing personal protective equipment, we have reduced the likelihood of the chemical coming in contact with the user. And to decrease the consequence, of course, by using chemicals that are less toxic and so on, we reduce the consequence of the chemical impacting or having adverse effects on the user. So there are several steps involved in carrying out a chemical safety risk assessment. And these include, number one, examining the processes that are involved in a given job. Number two, identifying the hazards. What are the potential hazards? We do this for chemicals by looking at the safety data sheets. And number three is characterizing the risks that are posed. And this includes looking at the likelihoods and the consequences. And number four is identifying if that risk that has been characterized is acceptable or not. If the risk is acceptable, we will proceed with doing our job as it is. But if the risk is not acceptable, then we will have to implement additional controls and measures until we reach a situation where we have an acceptable risk. Now, for chemical security risk assessments, also involves 6 steps, but in this case we are not looking at hazards but at threats. Therefore, the first step is to evaluate the threats that, or the people who might want to take or steal or acquire the chemicals in an illegal way. After identifying the people, we need to identify the assets that are likely to be targeted by the threats. And the third step is to characterize security risks, which is again looking at the likelihood and the consequence of a threat accessing the chemicals. Then the fourth step is determining whether the risks are acceptable or not. If they are acceptable, we proceed with our usual operations. If the risks, the security risks, are not acceptable, then we implement additional measures until we reach a situation where we have acceptable risk. So it is important to note that there is no security risk or safety risk that will result in a zero risk. That we always have to carry out the different steps to reach such a situation where we have acceptable risk. In conclusion, chemical safety and chemical security risk assessments are important. The assessments must be made in order for us to identify where we are in terms of protecting the users of chemicals and protecting the chemicals from threats, so that we reach a situation where the chemicals cannot be accessed or used in a manner that would harm users or the populations in the areas where we live and work. Thank you.